Let us now talk about electric current. Now, electric current, of course, is defined as the rate of flow of electric charge. And so if you think of a bunch of charged particles flowing in one direction like this, that's pretty much a current. And so I, of course, is defined as Q over T. And of course, we can rewrite this to say that the total charge flow is simply the current times the time over which the current flows. Now, these formulas are always very useful when we deal with average currents or direct currents, or well, currents that basically don't change in magnitude. Of course, there is the more generic form of the current, which is dq dt, right? And in which case, this will be, of course, a little bit more useful, right? If we have a current that's changing over time, and how we can look at this if I plot the charge accumulation curve, right, which looks something like that maybe. And of course, the current is simply the gradient of this curve at any one moment. And of course, if I think of the total charge accumulated because of a varying current, then I can write it as Q equals to integrate I dt, in which case again, right, if I give you an IT graph, it looks like that. Okay, the total charge accumulated between any 2 points of time is the area under the curve. Now, let's also bear in mind that current, while we define current as a flow of charge, sometimes it's more useful to think of it in terms of a flow of charged particles. Then it's something we can visualize. In the A levels, most of the time, current is due to a flow of electrons, like so. And so we can actually write current in such a way, Q over T, where the total charge Q is simply the number of electrons Ne multiplied by the charge of each electron, the elementary charge over T. And then you see we have an interesting way of expressing this current as the rate of flow of electrons Ne over T times E. And so, for example, a current of 1 ampere, okay, I can figure out how many electrons flow past a point per unit time, okay, simply by saying Ne over T is 1 ampere over E, which is this, and you get quite a large number actually, 6.25 times 10 to the 18, which is quite a lot of electrons if you think about it. Now, the current, when we study circuits, we have always been taught that it flows from the positive terminal to the negative terminal. This is of course called conventional current, and this is the current that we will use to analyze most circuits. But in reality, since we understand that current is essentially, or most of the time, a flow of electrons, electrons, of course, should be flowing the other way from the negative to the positive terminal. And this is what we call the electron flow. So just bear in mind that this is what actually happens, right? Electrons flow from the negative to the positive. But by convention, we will still use the conventional current, which flows from positive to negative in all our circuit analysis.